Okay. Everybody has their notes? Ready to go? All right. Just so you know this, and I know I probably don't have to tell you. How many days are after school?
27.
Oh, you guys don't know.
27.
28. But now listen closely. Listen closely. It's 28 days. The last 5 days of school are for your second semester test. And I need 3 days to review with you. So that's 5 days. So 28 turned into 23. Seniors, where are you at, seniors? Where are my seniors?
There's 9.
We don't have seniors in here?
No, Ethan dropped.
Awesome. So we don't have to worry about it. Seniors would have had to speed up because they're leaving 2 days early, so we don't have to worry about that. That's good. Okay, so guys, what it means to me is this. You got 23 days. 23 days to do chapter 7. Probably get a couple lessons, maybe 3 lessons in from chapter 8. So really, there's not much left. I was going to try to have your grades all ready for you today. I'll do it tomorrow. But your grades, I've got your grades updated all the way as if today ended. If today was the last day of school, I was going to give you your grade just to show you where you're at. I'll do it tomorrow. When you see it, you got 23 days to change that grade. If you like your grade, all you got to do is maintain what you've been doing. You don't like your grade, you have a chapter and a half to change it. Really, if you're missing a B or a C just by a little bit, you can get it. If you're missing an A by a little bit, you probably can get it. Be careful if you have an A or B right now, because obviously you can't slip. Okay, you still have a month left. All right, here we go. This is chapter 7. Chapter 7 gets into what we call exponential models. Okay. I'm not going to read this to you. You come back and read it later. You'll see what we're doing in just a little bit. As you move down this thing, I'm going to cross this up. I don't really like this right here. So I'm going to go like this. Because this is mentioned on the second page, and the second page does such a better job. So get rid of that. This problem down here, we're going to graph it, but not until the second page is half done. Okay, here's the second page. Are you there? Turn the page. This is really where we're starting right here. We are working with exponential functions. And I could read this to you, but you're going to get a little lost, so let's not read it yet. Let's kind of talk about exponential functions. Okay, on the top, where you see you got about a ½ inch margin on top, right? Write this down. Okay, somewhere on the top. Exponential functions. These are brand new to you. Well, you know what? I shouldn't say brand new. You did them in Algebra 1. I don't know if you remember them, but you did them in Algebra 1. They will look like this. Y equals A times B to the X. This is the look of an exponential equation. How do we know? How do we know that?
Because the B has an exponent.
Because what?
Because the B has an exponent.
Because the B has an exponent, yes. But wait. There's an exponent. This was called quadratic. What makes that exponential?
Because it's multiplied by another number.
Usually doesn't specify.
What? It's taken to the power of an exponent. Close. What do you notice about the exponent?
It can be any number.
It doesn't matter.
It's what?
It's not a number.
It's not a number. It's a what? It's a variable. So guys, whenever you see this, whenever you see the exponent is a variable, you know right now you have what? You have an exponential function. This is how I know I have exponential. So if I see this, 3 times 2 to the x power, I see x is in the exponent spot. This is exponential. Okay, that's how I know I have exponential. All right? Now, hang on, I want to tell you something about exponential. This will be a number. This is a base. This number in front is called the coefficient, the number times your base. Okay, so we split into 2 different types of exponential. One of them is called growth. One of them is called decay. How do you know when you have growth?
Goes up.
The graph will go up, right? But just looking at that equation,
If B is greater than 1,
if B, the base is greater than 1, he's right. You will have growth if the base happens to be what? Greater than 1. Okay, so here's an example. Y equals 10 times 3 to the x. Which number are you looking at when it comes to, is it growth? Are you looking at the 10 or are you looking at the 3?
3.
You look at the base, it's the 3. You don't even care about the 10, you only care about the base. Base is bigger than 1, it's growth. So what's decay?
1 is
When it's what?
Less than 1.
When the base is less than 1, okay, so let's write that. So decay happens when the base is less than 1, but
greater than 0.
greater than 0. Okay, an example of that would be y equals 10. Somebody give me an example. 1/4, 0.5, yep. To the what? To the x. Okay. Do you get the difference between growth and decay? Okay, you just look at the base. Base is bigger than 1, growth, base is between 0 and 1, decay. Quick, a sketch of the graph, just a sketch. I'm not really graphing it, but a growth graph will always do this. It will start, on the left, it will start really, really small. It starts to grow slowly, slowly, slowly. And then about when it hits the y-axis, it really starts to take off, and it will look like this. They all look the same, they just cross at different points. That's growth. Where decay would be what? How would it start on the left? Say it again.
It seems it's really high and then it starts to grow.
It's really high, and then it starts to drop because it's decaying away. It's kind of floating away. And then at the very end, there's nothing left. And it just kind of rides out on the x-axis. This one rides the x-axis to the left. That one rides it to the right. Okay? Good? Do you kind of remember this at all?
Yeah.
You did this in Algebra 1. You probably did it for a week or something. We're going to do it for about a day. That's why you needs to kind of jar your memory. Okay. One more thing about your equation right here. This number right here, the a value will end up being your y-intercept. So your y-intercept will always be 0, comma, and in this case, what's it going to be? 0, 10. 0, 10. So what I'm trying to tell you is, what's this number right there?
10.
10. What's this one? 10, because this was 10. If this would have been 100, what's this point? 100. It's whatever the a value is. So really, I should put the y-intercept is 0, comma what? Don't say 10. It's always 0a. Whatever a is, that's your y-intercept. Okay, now let's go back and read what this says, and now it should make more sense. You're going to talk about exponential functions. What about them? They always look like this. Okay, when the b value happens to be greater than 1, you have what? Growth. When the b value happens to be greater than 0 but less than 1, you have decay. See, now it makes more sense now that I'm reading it to you, I hope. The y-intercept will always be what? 0a. It's this number right in front of your base, okay? Now this part I did not talk about, so be careful here. The domain, which is the what values again? No. What value is the domain? Is that the x or the y's?
The x's.
This is the x values, right? So the domain, known as the x values, is always going to be all real numbers. You can't go wrong unless you don't write it. If you don't write it, you get wrong. Here's a new word for you. What's the asymptote? I'll tell you in a second. Okay, now what about the range? The range will always be what? The y values. The y values will be what? Anything greater than 0. Now that's a very generic exponential graph. That would be like the parent. The parent graph, this is the answer every time. Okay, what's this asymptote thing? This asymptote is this. So this way. Yep. Okay. The asymptote happens to be a line that your graph approaches and never touches, never crosses that line. Do you see anywhere on here? Where do you see a line that your graph comes close to? The what?
X-axis.
The x-axis. The x-axis is called the asymptote. It's a line, it's just a horizontal line that your graph will ride right on top of but never touch. Now, when I say what's the asymptote, you tell me an equation. What's the equation to a flat horizontal line? Y equals what? Yeah, crosses right at 0, so yeah, there it is. This is the asymptote for every generic exponential equation. Now, generic means the parent, okay? All right, go back, and now if you read it, it says right here, the asymptote is always going to be what? Y equals 0. But again, that's just the parent. Tomorrow we're going to do what with these graphs? What do you think we're going to do? Move it right, left, up, down. I did it all backwards, didn't I? That was kind of weird. It's because everything's opposite for me, you know what I mean? Answer those 4 questions. Is this growth or decay? Growth or decay? Put a G for growth, put a D for decay. Go. You got 10 seconds because it takes no time. D or G? D or G? Yes, they can be, but again, that's tomorrow. Let's not get into it yet. Okay, what is it, guys? G or D?
G.
G. Tell me why you said G. Is it the 3 or the 5 you looked at? It's the 5. 5's bigger than 1. G or D?
Q.
G. What would you look at?
7.
Not the 1/2. You looked at the 7, I hope. G or D? D. You looked at 1/3 is less than 1. And what's this? D, decay. This is less than 1. Okay? That was easy, right? Okay, do it again. Look at this equation. Is this an example of growth or decay? And then, what is the what? What's the y-intercept? So you got to tell me 2 things. Growth, decay, and what's the y-intercept? Aaron, growth or decay?
I say growth
Why? Why'd you say that?
because the number in the parentheses is more than 1.
Okay, the number inside the base is 4, which is bigger than 1. Good, you got it. Aaron, what's the y-intercept? You don't know? Okay. Will, what's the y-intercept?
3.
Just, you want me just to write 3? Remember the y-intercept is a point,
Oh, 0, 3.
0, 3. And where are you getting that from, Will?
From the A.
It's the a value. Remember, this is a times what? B to the x. A is the y-intercept. And if you guys don't trust that, then just put the number in. That's what I would do. I'd stick this 3 right about here and ask myself, what's 4 to the 0 power?
0.
4 to the 0 is 1. And 1 times 3 is 3. It works. So you can do it yourself, but why would you do it yourself when you're staring at the answer? It's right there. Okay, next. Growth or decay? I'm looking here, guys. Branson, what do you think? He says decay. Because why? Okay, 0.7 is between 0 and 1. He's got it. What's the y-intercept? He says 0 goes in and 0 comes out. Everybody agree? You're all wrong. What? You think 0, 1 now?
Yeah.
Okay, let's look. Let's rewrite this thing. Y equals, here's the base, 0.7 to the x. They didn't write parentheses for you, so then you thought there was nothing there. There's a number here. What is it?
1.
It is 1. So the answer is 0, 1. Okay. Again, you would have known you're wrong if you would have just put that 0, 0 in. Look, put this 0 in right here. Put it right there. What's 0.7 to the 0 power? What's any number? Any number to the 0 power? 1. Yeah, the answer is 1. I mean, you can do the work yourself, or you can look right in front. Now, that's a tricky one because you couldn't see the 1. All right? This is story problems on down, but we're going to go backwards and hit that graphing problem. We're going to graph 1. That's all we're graphing today. All right. They want you to graph this. Anybody want to tell me, is it growth or is it decay? It's 4 to the x. This is what it looks like. Look. You can look at it. Yes, yes. This is it. Starts low and it will go high. Okay. Start putting the numbers in. This would go here. So you do 4 to the 0. Then 4 to the first. They're giving you all the x values. 4 to the negative 1, 4 to the negative 2, 4 to the negative 3. Fill in the answers. I would start with 4 squared. 4 squared is so easy. And then work your way up. Alright, don't want to take much time on this because it's not that hard. 4 squared is 16. Okay, that one's done. Next one is what?
4.
4 next.
1.
1 next.
1.
Don't tell me 0.25 because that tells me you did it on your calculator. 4 to the negative 1 is really just 1 over 4 to the positive 1. What's the answer? 1/4, right? What's 4 to the negative 2? 1 over 4 to the second. 1/16. 4 to the negative 3 is 1 over 4 cubed. 1 over what? 64. Right? And what do you notice about your y values as I go this way? They're getting smaller, 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 smaller. How small am I right now? Very small. What's this number? Just a little bit bigger than what?
0.
A little bigger than 0. If I kept going, is it ever going to get below 0?
No.
You sure?
Yeah.
If I tried negative 10, 4 to the negative 10,
It's just 4 to the 10th power.
it's 1 over 4 to the what? 1 over 4 to the 10th. You know, 4 to the 10th is a huge number. But when you say 1 over a huge number, you're talking about what? A super tiny number, like just a hair above 0. So this is never going to get below 0. So when you graph it, oh, by the way, we got a problem here. Well, let's go. That's your problem. 16. What'd you do?
1 pass.
What?
You 1 pass.
Well, your scale goes up to 9. Did anybody change your scale?
No.
Nobody did? You somehow fit 16 on there, huh?
Yep.
I would have went by 2s.
I just crunched numbers.
You did, huh? 2, 4, 6, 8, 10, 12, 14, 16. I would have went by 2s. Okay? So 216 is here. 1, 4 is here. 0, 1 is here. And you can see this thing is shooting up really fast. But as soon as you get to the negative side, negative 1, 1/4. Negative 2, 1/16. Negative 3, 1/64. you can see it pretty much does what now? Rides the what? What's it riding on top of?
The thing I can't pronounce.
The x-axis, the asymptote, yes. Asymptote. Okay? Alright. I know it sounds like a funny name, but it's just simply this. Your graph approaches a line, but never touches the line. That's the asymptote. Okay, let's do this quick. What's the domain? What's the range? And what's the asymptote? Okay, here we go. The domain are the x values that get answers. All you got to do is look at your x values. Did 1 get an answer? Yeah. Did 2? Yeah. Does 5 get an answer?
Yes, sir.
It will eventually get an answer. How about the negatives? Did -4 get an answer? Yeah. What's getting answers? Yeah. All x values get answers. Just say all those. Okay. The y's, that's the range. What y's came out of this thing? 16 did, 14 did, so did 12, so did 10, 8, 6, 4, 3, 2, 1.
Everything greater than 0.
Yes, every number came out for y bigger than 0, but not 0, and no negatives came out, so we have to say y is greater than 0.
Will we ever get negatives?
Yes, you will, because tomorrow, you know what's going to happen? We're going to graph it, and it's going to be reflected over the x-axis. Yeah. Okay, asymptote, what line does this approach but never touches?
X-axis.
The x-axis, but what is the equation to the x-axis? Y equals what? What's the equation to horizontal line?
0.
Y equals 0, yep. So the asymptote is an equation, just so you know that. It's an equation of the line your graph cannot penetrate, okay? That's it. And that will change too. I think, Adrian, you asked that question. Can it change? Sure it can. Because you're going to go up, down, right, left, reflect.
Pipe it up a street.
All right, next. Here we go. Okay. Now, we're going straight to story problems. Okay? But here's the deal. You already know enough to pretty much do these story problems. You're going to either get a growth problem or a decay problem. Now, there's 2 formulas. What they did is they took this formula that I gave you, okay, and they said to make it a growth kind of story problem, change your base to something greater than 1. How do they make it greater than 1? They go over here, and they go with this formula right here. Okay, they say A, what you start with, times 1 plus R. R is the growth rate, how fast you're growing. Raise it to the t power. What's t?
Just the variable.
It's the time period. So if I tell you you grow 5% every year, that's your time period. So 5 years from now, put a 5 in. 10 years from now, put a 10. What if I said your time period was every month? And I said, let it grow for 2 years. What would you put in for t? 24. 24 months and 2 years. So you got to pay attention to the time periods, okay? All right. Now look at the formula for decay, guys. Look. Look at decay. Look at growth. Here's growth. Here's decay. What's the difference? What do you mean by adding and subtracting?
In the parentheses, it's 1 plus R, and the parentheses
Good, good. In the parentheses, it's going to be a 1 plus R if it's growth. In the parentheses, it's going to be a 1 minus R if it's decay. Everything else, dead even. It's all the same. So all you got to change is the plus or the minus for decay and growth. Okay, one more time. What's this A value?
1.
Well, read right here. What does A stand for? Yeah, the starting point. What did you start with in your story problem? Then you're going to grow by what rate? The growth rate is called R. What does the T stand for? Time periods. How many time periods went by? You have to know that stuff to do these, to work with these problems. Okay? All right. Move on down. Here we go. Read that problem. Tell me, is it growth or decay? How do you know it's growth?
Because it was all they were all greater than no, yeah.
What's greater than 1?
The value, the
Interest.
B value.
The B value, okay. How do you know the B value is greater than 1? How did you know it was growth and not decay?
B value is 500.
No, the B value is not 500.
Well, the B value is 103.5 because it says it pays 3.5% annual.
Yeah.
So when it pays, you're doing 103.5%.
Okay.
When you're losing, you're doing.
All I wanted you to say was this. How do you know it's growth? Because of this word right here. If it pays you 3.5%, you're getting paid money. You put money in, you get paid. You're growing, guys. That word right there tells me it's growth. Okay, so if it's growth, I'm going to do this. I'm going to fill this formula in right there. And then over here is your answer. This would be like the value of your account after T years. I don't think they used the letter V up there, did they?
A.
They used A. I like V because it's always the value of your account or the value of your car or motorcycle or home. Okay? Use V. Value of your account after T years. Okay, what's the starting point? Where did we start? 500 bucks, right there. You invest 500. Put it in for your A. Now you know if you take 500 times 1, did you grow? What's 500 times 1?
500.
You didn't grow. You didn't shrink. So now what do we have to do? We add the growth rate on. What's the growth rate? 3.5%. You can't put a percentage in a formula. You change it back to a decimal.
0.035.
Yeah, move it 2 to the left. 1, 2. 0.035. And then for how many time periods went by? 5. Every year you get paid interest.
Would it be 0.0 or 0.25?
Say again.
0.35.
0.35? No.
Oh.
0.35 is 35%. That's going to get you way too much money. Okay,
There's no such thing as too much money.
500 times. I wouldn't punch that in. I would just add it in my head. I'd get this. That's what I would do. Although, if you don't want to add it in your head, just punch in the 1 plus 0.035. Still works. Hey guys, I'm writing you this little message down here because I want you to know what V of 5 means. V of 5 means the value of my account in what? In 5 years equals how much?
$593.03.
$593. Eric, I didn't hear that.
84.
84 cents. Okay. So how much money did you earn? Yeah, $93.84. You guys, your money made you money. You put your money to work. And if you have money, don't let it sit in an account that gets nothing. Make your money work for you. You gained $93 in how many years?
5.
That would be incorrect.
Huh?
If it's compounded annually, it would be more than that.
No, we did annually. This is right.
Well, no, because if you took like 3.5% of 500 in the first year,
Yep.
you get a new total, then you compound that again.
Yep. And that's what this formula does. It compounds it for you. You know what?
Compounds it as 1.
You know what 3.5% is? It's $3.50 for every 100. You have 500. So that means 3.5 times 5. You're talking $17.50 for 1 year. But the next year you're going to earn more. The next year more. This is the final answer after 5 years. This is compounded interest. It is. Okay, you guys okay with that? Did you punch it in yourself? If you're not punching it in, others are doing your work. Okay, do it again. Right here. Third page, last page. Here we go. It looks the same, but it's not. Everybody agrees it's growth?
Yeah.
Okay, good. 1 plus R. What'd you put in? What did you put in for A?
500.
Yeah, you're still going to invest 500, right? 500 times. Okay, 1 plus something to the T power. Do they give you the growth rate?
Yeah.
Where is it?
0.0.
Okay, right here. Yep, you're right. 0.035. Do they tell you how many years to figure this out in?
No, but they
No.
give you an end amount.
Yeah, they say, when will? That means find the time. How many years does it take for your account to contain how much? 650? That goes right here, guys. They're telling you the answer. They're saying 500 turns into 650 after how many years? So this becomes the variable you're looking for, T. So this is kind of a different type of problem. You got to find out the exponent. How do you do this?
You should.
You got to solve for T, guys. Solve for T.
Can't you just divide by?
Okay, can I do something here?
Sorry.
No, I'm just going to do something here. This is really 1.035 to the what? T power. You need to get that T power by itself. What's the first thing you do? By
T.
divide by T.
500.
Yeah, I like your 500 a lot better than T. This to me says times. The opposite of multiplication is division. I just divide 500 by 500. Get over here and divide by 500. You're going to get 1.035 to the T power. Equals what?
13 over 10.
1.3. Okay? Now, here's the problem. You guys don't know how to solve this problem. You will know. You will. It's a book assignment. You want that paper? Okay. You guys, you will know how to solve this problem in about 6-7 days. I'm going to teach you something next week. For right now, this is trial and error. You have to use your calculator, come up with a number for T, this to this power. When's it going to be 1.3? Well, you already did this on the previous problem. You know when you let it sit there for 5 years, that money grows to, what do we get? 593. Okay, I would say if you want it to grow to 650, put a number in for T that's bigger than 5. 8? Okay, 8's not good enough. What does 8 give you?
1.316.
Say again?
1.316.
Okay, so you're just a little too high. You're too high. Come down. I don't want, it doesn't take 8 years. It's a little less than 8.
7.7.
What's 7.7, Eric?
1.303.
303.
Yeah.
You know what? I think all day we've decided that's close enough. So this is saying, okay, I don't have a method to solve this. I will in about a week and a half. The time it takes to grow this money into this money will be roughly 7 years. That is going to be about 7 years and 8 months, something like that. So it takes that long for your 500 to turn into 650. There's no easy way to get that answer today. You just have to start typing it into your calculator. You okay? That's kind of one of the nastier problems you're going to do, because there's no way to get that answer unless you just sit there and type. Now you probably start with 8, might go down to 7.5, back up to 7.7, back up to 7.8. You'll eventually get something you like. Okay? All right. These last three problems are very straightforward. You just use one of the models. Use a growth model, use a decay model to find the answer. Okay? So let's just try these three. I'll give you about a minute head start. First figure out, is it growth or is it decay? Did this word give it away? It's growth. First one's growth. So you should be plugging in numbers, right? They use the word value. So what's the value of my home after how many years go by? 14 years. Okay. So what did I start my house? I bought my house originally for how much?
125.
Yeah. There's your A value. Times 1 plus R to the 14th power. What's R though? What's the growth rate? Point 0.023, which to me, I just do this. This is what I type in. Answer, Gavin.
I got 1.449.
Say again.
1.449.
1.449. 1.449. $1.44.
That's not that valuable.
That house went from 125,000 to $1.44. Ouch.
I knew it was wrong, but that's just what I got on my computer.
No, I know. That's a bad investment, just so you know. Is it?
So
One. 171,857, and the cost is nearly 66 cents.
66 cents. Okay.
Yeah.
I think that's what it is.
Yeah.
Okay. Right? Most everybody get that? Okay. So is this true? Is this true, guys, that you can turn a house that was 125 when you bought it 14 years ago? Can you sell it for that?
Oh yeah.
That's what you want.
Is that how it works?
Add a toilet.
Is that about how it works?
Yeah.
Houses don't depreciate. Houses appreciate. You hope when you buy a home that you can get, by the way, if you can get 2% appreciation, that's awesome. I would hope for 1. If my house went up 1% each year, I'd be like, yeah, 2.3, that's great. Look at this house. This guy buys a house for 125, he sells it for 170. He just made what? Close to $45,000. And by the way, 14 years from now, he doesn't owe 125. Probably owes about what?
Well, depending if you got a 30 or.
Yeah, it depends, yeah. But I'm just guessing, probably 50, 60. He owes 60,000. Sells it for 170. He made over $100,000. That's a great investment. That's why people do buy homes. It's a great investment. Although you gotta have a lot of money to be able to buy homes.
I bought a home because I want to live in a home.
That's why you do it. That's why you do it. But it is a good investment. Renting is okay. The only problem with renting is you don't own it. It's not yours.
No, but it's great to be a renter.
If there's lots of repairs, you're right. Here's a motorcycle. For $25,000 motorcycle, it decreases at 18%. Are you thinking what? Growth or decay? Decay. It's decay, guys. Value of your motorcycle after 3 years. $25,000. What do you put inside those parentheses? 1 minus 18%. 0.18. Not 0.18, because that'd be like 1.8%. Okay, for how many years? 3. I will tell you this, I don't type that in my calculator. I actually do the work, and I usually can do it in my head because 1 just means 100%. So you take 100%, you take off 18%, what is your motorcycle worth next year? 82%, yeah. So really what I type in my calculator is what is my motorcycle worth? 82%. So basically every year that goes by, yeah, I lose 18, but I still have 82% left. Type away. What do you get? How much can you sell it for in 3 years? 13,000 what?
784.2.
Okay, and 20 cents? Okay. So did you lose a lot of money? Yeah, you lost almost half the value of your motorcycle. That's not the
You
greatest
gained
deal.
memories.
It's the memories that count, Harry says, right?
Yeah.
Popping the wheelies, living on the edge, right here.
Did you ever have a motorcycle,
Okay.
Mr. Painter?
Huh?
Did you ever have a motorcycle?
I rode a dirt bike when I was younger than you guys.
What happened?
Loved it.
What
Mr.
happened?
Painter.
Loved it. It was great. I didn't have a biker family.
Mr. Painter.
My biker family was across the street. It was great. Yes, sir.
If you want to retire and do something highly, I know you can
You can get one at your place? Okay.
That sounds like a great good life crisis.
Yeah, I kind of
get. I can even get to the leather jacket.
Harry, I'd probably kill myself. Do the last one, guys. Hurry up, hurry up. Get started. This one's kind of difficult. Get started. No, there's not. We'll be started.
I got the equation right now.
Well, no, because this is a percent.
Because the bell's gonna ring, this is the setup. Look, look, look. Okay, you have to solve this one for R. And when you solve for R, you find out R is 1/3. Okay. Yep. Oh, shoot. You're right. That should have been a 1. Because it was after 1 year. You're right. Solve it, you get 1/3. R is 1/3, but then you have to reuse that again.
Oh! It's a problem inside a problem.
Do your best on that one.
Mr. Painter, let me get that one.
Yep. I gotta shut this down for Ms. Schmidt. I have a dentist appointment. I'm not gonna. No, I'm sorry.
I think